This is Mike Biel. I'm going to go over lab exercise 5, which is a strain gauge rosette applied to a thin-walled pressure vessel. And this is our pressure vessel, an A&W root beer can with root beer. And the strain gauge that I selected came from the Mercury Marine inventory. It's what I had available. It's a 120,000th of an inch grid pattern size. It's a stacked rectangular rosette. So with gauges at 45 and another 45 degrees apart. And it's 350 ohm. And it's appropriate for aluminum, which our can is made out of aluminum. So first is the surface preparation, abrading the surface. And it was surprising there is actually a fair amount of dents on the can that are not visible until you start removing the coating. So skipping a few steps here, but all proper steps were taken. Next then, I'm ready to apply the rectangular rosette. It has integral lead wires with it, and they have a rectangular cross section, so they are difficult to bend in a lateral direction, and they're kind of hard to work with. And then I have solder tabs, a set of solder tabs for each of the sides of the rosette. Okay, so I have a few pieces of tape to cover all of that surface area, and here I have the rosette on the can. It's going on in any arbitrary direction, so there was no alignment performed. There's no burnishing marks on it. That's part of the assignment, is to put it on in an arbitrary angle, and so it's ready for bonding here. Next is the lead wire attachment. Now the lead wires are attached, and I ran each side of the rosette to be measured as a quarter bridge, so individual, and then I ran them, of course, then as 3-wire configuration. There's M code A applied over these lead wires, going from the solder tab to the grid itself, to provide strain relief and just protection, and also is providing electrical insulation between the can and those small lead wires. The measurements were performed with a LMS Scatus Mobile. It's a 5-slot frame, and so it has the VB8E card for measuring strain for doing bridge conditioning. And all the measurements were measured at a sample rate of 64 hertz. That's the lowest sample rate. And here's a list of the measurement sequence that was performed. So after the gauge was applied, the bridge was balanced. The strain gauges were calibrated using an internal shunt calibration procedure inside the LMS Test Lab software. And then the starting pressure, the pressure in the can as received with the strain gauges applied, was recorded. So that was close to zero strain, because the gauges were applied when there was a strain state on the can already. Then I shook the can up and took a measurement while shaking it, and then I measured after I stopped shaking to see how the pressure may decay. And then I opened the can and recorded that event. And then you'll see there are 8 calibration steps there, 0 through 70 psi and 10 psi increments. I also installed a Legree fitting onto the soda can so that I could pressurize it with a pressure calibrator, and then calibrated it using a Druck calibrator. So this is getting ready to shake it up. And the pressure was discharged by putting a hole in the bottom of the can. The top of the can stayed closed. This was the most convenient place to install a Legree fitting. So that was drilled and then epoxied into place. And then you can see the Legree tubing connects the pop can to the Druck calibrator.